Welcome to your podcast on using statistics in your research, presented by Richard Frett for the Educational Media Design and Technology program. In this podcast, you'll learn basic statistics that everyone should know. We would assume someone with a master's degree has a basic level of statistical knowledge. We'll also talk a little bit about how you can use statistics in your own research. So why should we use statistics? Statistics are a great way to check the accuracy of our observations in an objective way. We can also compare our results to other people's results, and statistics also give the appearance of academic rigor, showing that you've looked beyond just the basics in what you're doing. First, let's discuss the difference between quantitative statistics, which is what we'll be discussing today, and qualitative statistics, which is also an important part of what you will research. Your qualitative side includes interviews, observations, anything that can't be represented by numbers, while the quantitative side is anything that you could count, represent by numbers or formulas. We'll refer to the data that you collect as a variable. Variables can be independent, or dependent, or confounding. The independent variable is the part of the experiment that you plan to change. For example, you vary the amount of technology you use in the classroom to see how that affects your student test scores. Your independent variable is the level of technology use, and then your dependent variable would be the test scores. Confounding variables are anything that affect the experiment that you need a control for beforehand. For example, if you're comparing the scores on two different tests, and one class is before lunch and the other class is after lunch, the food in the student's stomach may have an effect on their test scores. Two important concepts in statistical or any type of research are validity and reliability. The validity of a research tests how well what you're researching actually measures what you intend to research. For example, there's a lot of use of standardized tests right now to measure student scores. Unfortunately, standardized tests not only measure what you're trying to measure, they also measure how good of a test taker the student might be. So we can say these tests may not be valid, that they're not measuring what they intend to measure. Grading papers or analyzing observational data may get a more valid score. Unfortunately, these tend to be less reliable because if you give a paper to 3 different graders, you may get 3 different scores on that paper. Validity and reliability sometimes are linked but are often independent of each other. For example, say that I weigh 180 pounds. I can have a scale at home that measures my weight. Perhaps I stand on the scale once, it says I weigh 180 pounds. I get off and I stand on it again, it says I weigh 182 pounds. I get off and stand on it again, it says I weigh 178 pounds. But it's always around 180 pounds, which is my actual weight. We would say that that scale is accurate or that it has a good validity because it's measuring about what I actually weigh. However, the scale is not precise. It does not have reliability because it gives a good variation of what I weigh. Say I have another scale. I step on it and it says I weigh 187.2 pounds. And I step on it again. It says I weigh 187.2 pounds. So this would be a very precise scale. Every time I step on it, it gives me exactly the same weight. So it has good reliability. However, the scale is not accurate. It does not have validity because it's not giving me my actual weight. Why would I want a scale that's not accurate? Well, if I were losing weight, I could use the scale that's much more precise but not accurate to see how much weight I lost. With the scale that had good validity, which was very accurate, the one that said I weighed about 180, I could never tell if I'm actually losing weight or if it's just a variation because the scale is moving it all the time. So having a more valid scale for that purpose is actually worse for the purpose. Another important part of basic research design is sampling. Sampling is how I choose the subjects of my research. For most of the people in our program, you're stuck with the sample that you've got. You've got a class you're teaching and you need to sample on them. In a true experimental sense that would have lots of reliability and validity, we would have to choose our samples carefully. First, you want to choose a sample that's representative of the group that you want to study. If you want your results to be generalizable to the group of all 10th graders, you would have to get representative groups of 10th graders from all socioeconomic statuses, all racial groups, and all areas of the country to make it generalizable. In general, a larger sample gives you better reliability. If I study 1,000 people, I can get better data than if I study 30 people. When you're reporting data in your research reports, make sure you use the number N, capital N, to represent the large group of people. If you have a class of 29 people, you would say capital N italicized equals 29 to represent that class. If you break your larger group into smaller groups, use a lowercase n to represent the numbers there. So if I broke my class of 29 into a group of 15, group of 14, I would say n equals 15 for one group and n equals 14 for the other group, with a lowercase italicized n. When you're breaking students into groups, make sure to randomize them if possible. Don't just take the first half of the alphabet or the second half of the alphabet or let them choose their own groups, because there could be possible complications there. So now that we have a basic understanding of statistical concepts, let's look at some statistical techniques. One important group of statistical techniques that everyone should be using are those that measure central tendency. We'll talk about mean, median, and mode, and show how skewing can affect which you should use. Mean, or what you probably call average, is probably the widest used statistic. To find the average in Excel, select your column or row, then look for the AutoSum feature in your toolbar. Click on the small triangle next to the sigma sign, then drag down to average. Your average will appear at the bottom of the column or to the right of the row that you chose. In the example shown, 6 test scores average out to 70.5 points. Unfortunately, 70.5 points is not a good measure of how this class did. If you look at the scores more carefully, you see that most of the students got well above 70.5, including 80s and 90s. In fact, only one student got below 70, and that was a 0. We call this tendency skewing. The 0 is an outlier that skewed the data in a negative direction. This often happens in a small sample. One way to alleviate the skewing is to use a different measure for central tendency. This measure is called the median. For a small sample such as this, finding the median manually is easy. We just order the scores from smallest to largest, and then find the score that lies in the middle. Since we have an even number here, we have 2 that lie in the middle, the 79 and the 80, so we average those out to get the median, which in this case is 79.5. For a larger sample size, finding the median manually might be cumbersome. Luckily, Microsoft Excel provides a way to calculate the median for you. To indicate to Excel that we're using a formula, start your entry with an equal sign. After the equal sign, we type the operation we want to use. In this case, median, M-E-D-I-A-N. After we type in the operation, we tell the software the range of scores we want to use. First, put in an open parentheses, then type in the column and row of the first entry. In our example here, the first number is in column A and row 2, so we type in A2. After the first entry, we put a colon to indicate that we're going to have a range of numbers and to use all numbers in between. After the colon, we type in A7 to indicate that that's the last number. After the final entry, put a close parenthesis and then hit Tab or Return. Microsoft Excel will automatically calculate the median. Another indicator of central tendency is the mode. Mode is used less often than the other two, but is still worth talking about. Calculating the mode would not be useful in our previous example. A better use for mode might be counting how many projects a student completes. In this dataset, there were 4 projects. The numbers show how many each of the students completed. Student 2 completed 3 projects, and student 3 completed 4 projects, and so on. We could simply count each of the categories. 1 occurs once, 2 occurs once, 3 occurs 3 times, and 4 occurs once. The mode is the number that occurs the most, which happens to be 3 in this case. We could also use the Excel function mode, which works in a similar manner as median did in the previous slide.